Hi, I'm Nicholas Dwork, and today we're going to be discussing excitation. Recall that in a particle of water, every hydrogen atom has a magnetic vector associated with it, and if that droplet of water is put in a large magnetic field, those magnetic vectors ever so slightly align with the external magnetic field to create a net magnetic vector. This is that net magnetic vector, and for different amounts of water, we would have different vector sizes. So a small amount of water would give us a small vector, and a large amount of water would give us a large vector. The sizes of these vectors is what MR images. So how does it do so? How does it see these vector sizes? Suppose the large external magnetic vector were along the z-axis as shown here, and the magnetic vector of the hydrogen atoms were perpendicular to it. Then the hydrogen's magnetic vector would precess around the external magnetic vector. It would rotate. And it rotates at something called the L'Amour frequency. For a 1.5 Tesla magnet, this is approximately 64 megahertz, or 64 million times per second. We can create a separate coordinate system that is rotating at the same frequency. And in this separate coordinate system, which we'll call the rotating frame, the vector is not rotating at all. And so it's like there's no external magnetic vector in this rotating frame. There's simply the net vector of the water. That rotation is what we're going to use to see the particle, but how do we even get this net magnetic vector into the xy plane? The answer is through a process called excitation. So we turn on a magnetic vector, B1. The hydrogen's magnetic vector precesses like it does before, and then we turn it off when the vector precesses into the xy plane. That's excitation. Note, it's stationary only in the rotating frame. In the lab frame, it's precessing like before at 64 million revolutions per second. So what we do is we put a coil of wire near the body, near this particle of water, an open loop wire. This precessing magnetic vector creates a voltage at the terminals of this wire. So we simply put a measurement device attached to the coil's wires, and those are the numbers that get recorded by the computer. Here's what one MR coil looks like. This is one sold by Philips. This is a rather small one, and it's used to see things close to the surface that are very small. Here's an MRI machine, and underneath the plastic sheathing of this MRI machine, there's a coil to sense larger parts of the body. It's called the body coil. Thank you for your attention.